The people have spoken, and Jugglebot will be red with green balls. I am pretty happy about this because there's a lot of printing that needs to be done, and I already have 2 spools of red filament ready to go, so I can start that printing basically now. In the meantime, I'll buy the new balls, and hopefully by the time everything has been printed and made, the balls will arrive. Now that the colors are resolved, the next big question is, where do I actually place the camera? I'm using these depth cameras, and I need to know where to actually put them so that Jugglebot can see the balls. The way that I went about solving this problem is by first modeling where the ball will actually be. If you remember anything from your high school physics class, it's probably that objects in flight tend to obey what's known as projectile motion. This provides a set of very well understood equations that model how objects move through the air, assuming no air resistance and that sort of stuff. Using these equations, I modeled a shape in SolidWorks that basically shows all of the places that the ball will be going. This does assume that Jugglebot is only juggling to itself, so there's the equivalent of one hand. And this shape would look quite a bit different with 2 or more Jugglebots, but it would be fundamentally the same thing. Something you may have noticed while watching people juggle is that they pay particular attention to the peak of the ball's path. This is because that's when the ball is moving slowest, and you can get a much better idea of where the ball actually is and where it's heading. For the same reason, Jugglebot will be paying attention to that peak a lot more closely than the base parts of the path. To make it easier to see where the peak of this volume is, I've colored the top 30% of it in this sort of like pinky purpley color. The next step in the process was to model exactly what this camera can actually see. It only has a limited field of view, and I need to know what that is so that I can place the camera properly so that it can see the ball. By putting this camera with its field of view volume into the model with the entirety of Jugglebot, including the ball path shape, we're very easily able to see exactly when the camera can see the entire path and when it can't. You can see this pretty easily here, where on the right hand side you can see what the camera can see. And when Jugglebot is positioned in certain positions, it really blocks the ball path shape, and that's not ideal. A problem that I noticed pretty quickly in this process is that there was a trade-off between the camera being closer to Jugglebot and the camera being able to see the entire path with less occlusion in the way. The occlusion here being the Jugglebot itself blocking the view of the ball in flight. This presents a problem because I want to fix the camera to Jugglebot's base so that I always know exactly where it is. If I don't do that, then I'm going to have to calibrate the camera every single time I turn Jugglebot on so that it knows where the camera is relative to Jugglebot. That's going to be a big pain in the butt, and I don't want to do that, so I want the camera to be physically attached to Jugglebot in a known position. After a bit of thinking on this, I figured out 2 solutions to this. The first is just more cameras. By having 3 cameras positioned all around the base of Jugglebot, there's no position where Jugglebot could be that will block all the cameras. So there'll always be at least one that can see where the ball is. I think this will be the most robust solution and would be the one that I would ideally do, but that introduces other problems like, how do I power the cameras? How do I connect the cameras to my Raspberry Pi that only has 2 ports, and the 3 cameras needs 3 ports? Not to mention the motors are going to be taking up one of those as well. So it's a whole nightmare. So the second solution that I thought of is to make Jugglebot only juggle in one plane. By doing this, it will never be in a position that fully blocks the view of the ball. It will sort of block it sometimes, but for the most part, the ball should be relatively unobstructed from view. I'm planning to upgrade from the Raspberry Pi soon to a more capable computer that has more ports, and this way I should be able to have 3 cameras, or at least 2, but for now, I think the planar juggling will suffice. You may have actually noticed in human juggling that we juggle in a planar manner. It's very, very uncommon that you'll see a pattern go outside of the front plane of the person. I'm pretty confident that that's just because our biology makes it a lot easier to do that. As far as I can tell, the patterns themselves are relatively agnostic as to whether or not they're being juggled in a plane or juggled in a more 3D manner. This does mean that Jugglebot will be very well poised to do tricks that humans find very difficult to do, but that will require that I get this camera situation sorted out. Now that we know where to position the camera, the next question is, how do we actually attach it to Jugglebot's base? And importantly, you might have noticed that where we've chosen to place this camera, it's pretty likely that it's going to be hit by balls every now and then. If the ball is not caught perfectly and it bounces off just a little bit wrong, the camera is right there ready to be hit. This was not a trivial object to model and required the use of pretty complex lofting and surface modeling that I don't really do that often, but I think the end result turned out quite nice and should do a pretty good job of keeping the camera and its cables safe. We'll see how it actually holds up once balls start landing on it, but I think it should be pretty strong. The next step in this process is to give some intelligence to the eyes of Jugglebot. And by this, I mean, we need some program that will take in what the camera can see and return what the position of the ball is. I've already done a fair bit for this process, but there's a lot more that needs to be done. So I'll be doing a follow-up video that goes into all of those details. So make sure you subscribe if you don't want to miss out on that. As always, I hope you found this interesting, and until the next one, have a good one.